In this lecture video, we will discuss some physical and geometric applications of double integrals. Okay, so first, recall natin na pag may function tayo of two variables na continuous and non-negative on a closed and bounded region R, then yung volume between the surface and the region R is given by the double integral of f over that region R. Okay? And napakita natin from the previous lecture na yung double integral ng 1 over the region R gives the area of that region. Okay, so as an example, let's find the area of the region enclosed by x equals y squared minus 1 and x plus y equals 1. So we will try to answer this using double integrals. So sabi natin, sa yung area na to is the double integral of 1. So to set up bounds for that double integral, kailangan natin i-sketch yung region. So take note, yung region natin is enclosed by this parabola opening to the right and this line. Okay, so sketching those two curves, we get this region. So verify nyo na lang on your own na yung intersection nila ay sa 0, 1 at saka sa 3, negative 2. Okay? So to set up bounds for our double integral later, kailangan natin pumili ng method of integration. So again, we have three ways: using vertical strips, using horizontal strips, or using polar coordinates. So, dahil ganito yung itsura ng region natin, mukhang okay gumamit ng horizontal strips, or we look at this region as a type 2 region na merong left curve tsaka right curve. So, makikita natin yung left curve ay yung parabola, x equals y squared minus 1. Yung right curve ay yung x equals 1 minus y, which is yung line na nire-right lang. Tapos makikita natin na yung y coordinates na covered dito ay from negative 2 to 1. Ayan, so with those limits, we have the following. Yung area, again, is given by the double integral of 1. Tapos using horizontal strips, we have this. Yung dA ay dx dy, x is from the left curve to the right curve, tapos y is from negative 2 to 1. So wala masyadong bago dito. Yung bago lang ay yung double integral ng 1. Ayan, tapos to evaluate this double integral, same steps as before. We first integrate with respect to the innermost variable. So integrating with respect to x, magiging x lang yung 1. Evaluating at the endpoints, simplifying, we get this. Tapos integrating with respect to y, evaluating sa endpoints, and simplifying, we get 9/2. So again, the area of a region can be given by the double integral of 1 dA over that region R. Tapos depende na lang sa itsura ng region kung anong magandang strips ang gamitin, kung horizontal, vertical, or yung radial strips from polar coordinates. Depende sa itsura ng region. Okay, now we move to another application of double integrals. Okay, so first let's describe or define what a lamina is. A lamina is a flat sheet of material whose thickness is negligible, or in other words, something that is flat enough to be seen as a two-dimensional object. So example, a sheet of paper and a galvanized iron sheet. Kung naman yan. Okay, so these things, flat enough sila para tingnan as regions na lang, or two-dimensional na lang. Okay, so ang gagawin natin, we will find the mass of such a lamina. So, i-model lang natin using mathematical objects yung mga nangyayari. So, suppose a given lamina is in the shape of a region R in the xy plane. Tapos, let f of xy be the density function of this region R. So, mangyayari dito, yung lamina natin, inhomogeneous siya. So, in other words, different points ng lamina, iba-iba yung density. Okay? So, hindi distributed yung kanyang weight. Pero nonetheless, so it's given by a function. Nonetheless, hanapin pa rin natin yung mass ng lamina na yon. Okay? So, yung density, again, yung f of xy. It's, when you say density for a lamina, it's mass per area, mass per unit area. Okay, so to find the mass of this lamina, we do a procedure na katulad ng ginawa natin for the volume problem. First, we subdivide the region into subregions. For this illustration, we divided into subrectangles, pero yung mga sasabihin natin gagana rin for yung ginawa natin sa polar coordinates. Anyway, yung point ay we divide R into smaller parts. Let's say we divided R into N subregions. Tapos let's call delta AK yung area no R sub K na subregion. Tapos pili tayo ng point xk star, yk star din sa subregion na R sub K. Okay, tapos we form this product. Pag in-apply natin yung F dito sa point na to, again, F gives a density. Okay, so pag in-apply natin sa isang point, density yon. Pag i-multiply natin sa area ng R sub K, we get density times area, which is mass. So this product here approximates yung mass nitong isang R sub K. Okay? So that, sa isang R sub K pa lang yan. So that, pag in-add natin yung mga yon, okay, over all R sub Ks, we get an approximation for the total mass of the lamina. Okay, tapos para gumanda yung approximation na yun, similar sa process natin before, we let n approach infinity so that the mass of this lamina will be exactly equal to the limit of this sum as n goes to infinity as we increase the number of subregions. Pero nakita na natin yung limit ng Riemann sum na to. This is the double integral of f of xy over the region R. Ayan, so napakita natin na yung, at least roughly, na yung mass is actually given by the double integral of f of xy over R kapag yung f of xy in-interpret natin as the density imbes na isang surface in 3D space. Okay, kapag dense, so again, kapag density ang f of xy, ang binibigay ng double integral of f of xy over R ay yung mass ng lamina in the shape of the region R. Okay. So, now let's define some other quantities involving a lamina. So, una, the moment of a particle about an axis is the product of its mass and its distance from the axis. So, yung axis there is just a line. So, when you say moment of a particle, mass times distance from the line lang yun. Okay. Next, we also define or describe the center of mass. So, the center of mass, sabi dito, is the unique point where the weighted relative position of the distributed mass sums to zero. So, ito yung technical definition ng center of mass. Pero physically, ganito lang siya. Kapag meron tayong lamina, yung center of mass niya or center of gravity, point yon such that kapag binalance natin or tinry natin i-balance yung lamina at that point, magbabalance yung lamina natin horizontally without tilting. So, yung point na yon, yung unique point na yon, yun yung center of mass ng lamina natin. Okay. So, this is, yung point na yon, again, yun yung center of mass or center of gravity. Okay, so ang gagawin natin for the next few minutes, we try to find that center of mass. Okay, first, let's compute the moment na gagamitin natin para sa pag-compute ng center of mass. Okay, so sabi natin, again, moment is mass times distance from the axis. So, for example, let's consider this lamina and let's consider a particle. So, a particle, let's say, yung shape niya ay itong R sub K na to. Okay. So, sabi natin kanina, okay, itong product na to, yung f of xk star, yk star, delta ak, ito yung approximation ng mass ng rk. So, ang gagawin natin, i-multiply natin yung distance niya from the x-axis. Yung distance from the x-axis, yun precisely yung y-coordinate, diba? Pag yung y-coordinate, distance yun from the x-axis. So, i-multiply natin yung yk star to get the moment of that r sub k about the x-axis. So, yung total moment about the x-axis ng lamina will be yung sum. Tapos, approximation pa lang yun actually. So, we get the limit as n goes to infinity. So, we will get this double integral. So, take note, ang nangyari dito, yung f of xy na multiply lang by y. Pag ginawa natin yon tapos in-integrate natin over r, we will actually get the moment of the lamina about the x-axis. Pag gusto natin kunin yung about the y-axis, we follow the same thing. Pero this time, ang i-multiply natin ay yung distance to the y-axis, which is yung x-coordinate. So, magiging x to, you can expect. Pero hindi ko na isusulat dito sa slide na to. Okay, so in summary, we have the following. Kapag meron tayong lamina in the shape of the region R with density f of xy, sabi natin, pag in-integrate yung density over R, that gives the mass. Tapos, from the previous slide, yung moments about the x-axis and the y-axis are given by these double integrals. Tapos, yung notation natin, paki-take note, medyo magkabaliktad dun sa formula. So, yung moment about the x-axis, yung notation m sub x. Pero yung formula, double integral ng y f of xy. Tapos, yung moment about the y-axis, m sub y. Pero yung formula ay double integral ng x of f of xy over r. Okay? So, with these moments about the x and y axis, it will turn out na yung center of mass, which is a point in the lamina, so may coordinates yon x by y bar. Yung coordinates are given by the following. Yung x bar is actually m sub y, so this integral over m, the total mass of the lamina, and y bar is m sub x over m. So yung double integral na to over m. Okay, so try not to be confused on these formulas. But for me, ang pangalala ko, yung x bar sa formula niya, yung nasa taas ay double integral ng x f of xy. Tapos pareha silang over m. Tapos yung y bar, yung y coordinate ng center of mass, yung nasa numerator ay yung double integral ng y f of xy. Anyway, so again, try not to be confused about these formulas. Okay, pero ito sila. Okay, so let's apply these to an example. Let's find the center of mass of the triangular lamina with vertices at the origin at 2, 0, and 2, 2 if the density at the point is f of xy equals 6 times x times y. Okay, so may mga formula tayo kanina. Okay, so yung center of mass, again, it's given by a bunch of double integrals. So to evaluate those double integrals, kailangan natin ng sketch ng region. So this is the sketch of the region of the triangular lamina. Triangle lang siya. Okay? So, since this is the line segment from the origin to the line to the point 2, 2, this is just the line y equals x. Okay. So, first, let's compute the mass of the lamina. So, sabi natin sa formula, yung double integral lang yon ng density f of xy over the region R. Okay. Tapos, again, at this point, meron tayong 3 ways to evaluate a double integral. Pero dahil ganito yung itsura ng region, triangular region lang, gamit tayo ng rectangular coordinates. Okay? In particular, gamit tayo ng vertical strips. Okay, so ito yung f of xy natin, 6xy. Using vertical strips, dy dx yon. Y will be from the x-axis, y equals 0, to the line y equals x. X is from 0 to 2. Ayan, so ganun lang. So again, kapag mass ng lamina, double integral lang ng density over that region. Ayan, tapos to evaluate this, same steps as before. Integrating with respect to y, evaluate sa endpoints, integrating with respect to x, evaluate sa endpoints. Ayan, so ito yung mass ng lamina natin. It's 12. Okay, next, to find the centers, the coordinates of the center of mass, kailangan natin yung m sub x saka m sub y. Okay, unahin natin si m sub x. Ito yung formula niya, sabi natin kanina. Okay, so we will integrate y f of xy. So, i-multiply lang natin yung f of xy ng y. So, we get 6xy squared. We integrate now 6xy squared over this same region as before. So, same region. So, dahil dyan, pwede natin gamitin yung same bounds as before. Ayan. Same bounds pero different integral. So, in the end, we will get most likely a different number. Pero same steps lang yung pag-evaluate. Okay, so ito yung moment about the x-axis. Okay, next, yung moment about the y-axis is given by this formula. Ayan, so halos same lang sa before. We multiply x dun sa f of xy, so 6x squared y. We get the double integral of that over this region, so same bounds. So integrating, tapos integrating again, we get this m sub y. Ayan, so nakuha na natin yung m sub x, saka m sub y. Ayan, tapos i-combine lang natin lahat yon to find the center of mass. So in the end, we will have x bar, which is again m sub y over m. Ito yung mga nakuha nating values earlier. So simplifying, we have 8/5. Similarly, y bar is m sub x over m, which are these two values na nakuha natin earlier. And this simplifies to 16 over 5. So, therefore, we have the coordinates of the center of mass, which is at 8/5, 16 over 15. Na, ito yung blue point na yan. Okay? I mean, yung blue point na to, ito yung 8/5, 16 over 15. So, take note, itong center of mass for this lamina with this density, yung center of mass niya, wala siya dun sa pinaka-center ng triangle. Slightly, mas malayo siya from the origin. Na makikita natin actually, based sa density, 6 times x times y, diba? Mas mataas to, yung value nito kapag mas malayo yung xy sa origin. Diba? Pag mas mataas yung x tsaka y, lumalaki yung 6xy. Ayan, so in effect, yung mga points na mas malayo sa origin, yun yung mga mas mabigat na parts nitong inhomogeneous na lamina na to. So in effect, na-shift yung center of mass away from the origin. Okay, pero in the end, okay, yung pag-compute natin sa center of mass ng lamina, formula na lang sila, pakialala na lang. Again, don't be confused with the notations and the formulas.